Hello everyone, I hope everybody is fine. We are going to have a quick review session for the upcoming test on quadratic relations. There's a whole bunch of different questions from different sections of this unit, and we'll try to do some review questions together. The first one, it says expand and simplify. There are two binomials. We need to multiply them, and we learned about the FOIL method, FOIL. We said that we have to multiply the first terms first. So x times x is x squared. And then x times negative 14 is negative 14x. And then we multiply the inside terms. 1 times x is just x. And finally, the last terms is 1 times negative 14, which completes the FOIL process. And then we have to collect like terms. You know that negative 14x plus x is negative 13x. So the final answer would be x squared minus 13x minus 14. So that's the final answer for the first expanding of the two binomials. Very straightforward. I hope you can get these kind of questions perfect on your test. Then we have a few review questions on factoring. We have a quadratic trinomial. We want to factor it. To factor means to write as a product, as it was explained in the past lectures. So in factoring quadratic trinomials, we said that we open and close two brackets, and then we look for two numbers that add up to positive 1, but their product is negative 42. So we are thinking of what are those two numbers that when you add them up, it gives you positive 1, the coefficient of x, and when you multiply them, it gives you negative 42. So by a little bit of thinking or trial and error on the scientific calculator, you will figure out that 7 times negative 6 is negative 42. So the two numbers we're looking for are 7 and negative 6. Actually, add them up, it's positive 1. Multiply, negative 42. And now we place x inside each bracket, so we could have done it before. And the final answer becomes x plus 7 times x minus 6. You can easily check this by doing the FOIL and see if you can get the original trinomial or not. Next question is another factoring question. And this one has only two terms. When there's two terms, there's a big chance that these two terms are perfect squares. And if they are perfect squares, we will try to write them in the form of difference of two squares. For example, 25t squared can be written as 5t all squared, and 121 can be written as 11 squared. You know that 121 is a perfect square, just like 4 is perfect square. A perfect square is a number that is the square of an integer. Let's say you have 4, which is 2 squared. Let's say you have 9, which is 3 squared. 5 squared is 25, so 25 is a perfect square. And here 11 squared is 121. And in order to find that 11, you can take the square root of 121 on your calculator and see if the answer is an integer or not. If it's a decimal, then the number is not a perfect square. But if you got an integer like 11 in this case, then that means that 121 must have been a perfect square. You can press the square button on your calculator. So now we have something squared minus something else squared. And that reminds us of the difference of squares formula. We said that a squared minus b squared equals a minus b times a plus b. If you remember, it was called difference of squares. So the answer is going to be here 5t minus 11 and then times 5t plus 11. So what plays the role of capital A in the formula is 5t, and what plays the role of capital B is 11, basically. You can also think of this as a trinomial whose middle term is actually 0. This is 25t squared, and then plus 0t minus 121. So you're looking for basically two numbers that add up to 0, like 11 and negative 11, but their product is negative 121. Just like positive 11 and negative 11, whose product would be negative 121. So you can think of it that way as well. But difference of squares is much easier to follow. This next trinomial, the first thing we have to notice perhaps is that there is a GCF, greatest common factor. So all of these terms have a factor of 3 in them. We have to factor 3 out first. This is the first thing we do in factoring questions. So I factor 3 out. X squared minus x minus, so if I divide 168 by 3, I get 5 and 56, I guess, yes? So 168 divided by 3, it's 56. So the first thing we do, we factor the common factor of 3 out. Now, the thing is that the question says fully factor, so we have to factor as much as possible. So we're going to say, okay, x squared minus x minus 56 itself is a factorable trinomial. So we're going to say two numbers add up to -1 with a product of -56 must have been -8 and +7. So we go x, and then we go -8 plus 7. Because if you add them up, it's going to be -1, the coefficient of x, as it has been explained extensively in the past lectures. And when you multiply them, it's -56. So that's the final answer for this factoring question. It says convert into standard form. This is a vertex form of a quadratic relation. You have seen this a lot in the past. We want to convert that into standard form. So the first thing we do is expand x plus 1. We're going to multiply it by itself. That's the meaning of exponent of 2. And then we're going to perform the FOIL, okay, multiplying the two binomials. X squared plus x plus 1 times 1 is 1, okay. And then we have collecting like terms inside the brackets following BEDMAS. X plus x is 2x, clearly. And now it's time to use the distributive law and multiply -2 by every single term inside the brackets. -2x squared minus 4x minus 2 plus 4, and that gives you -2x squared minus 4x plus 2 final answer. So that's the final answer for this question. Okay, -2x squared minus 4x plus 2. So that is the standard form. We started with the vertex form. We ended up with the standard form as it was required in the question. Next question says find the zeros of the relation. So in order to find the zeros, we have to write this quadratic trinomial in factored form or intercept form. So how do you factor this? It's needless to say, you open close two brackets and you go x inside each bracket. Two numbers add up to -1. The product -6 must be -3 and +2. So it's -3 plus 2. Because if you add them up, it gives you -1. If you multiply, it gives you -6, the product. So that's the intercept form or factored form of this quadratic relation. This was standard form. That one is intercept form. It says find the zeros. Well, you can just read it from the equation. R equals 3, and here S equals -2. These are called the zeros of the relation. They are also known as x-intercepts of the graph. It's the same thing, okay? So if this is a parabola, you want to graph it, it opens upwards. The two x-intercepts will be 3 and -2 clearly. Next one, again, it's a quadratic relation given in factored form or intercept form, and they're asking us to find the vertex this time. So just like the past exercise, I'm going to say the value of R is 6 and the value of S is -4, right? -4 and +6. So these are the two zeros of the relation or x-intercepts. Now, if you have the two x-intercepts, in the lectures we explained it before, that if you have the x-intercepts, if you find the average of the two x-intercepts, which is like midway between the two x-intercepts, that will be the x-coordinate of the vertex. I am sure, I have no doubt that you have reviewed the past lectures, past video lectures multiple times. I have no doubt you have taken notes, you know. So this is just review. You're not like teaching the whole thing. It has already been done. So what I'm going to do, I'm going to say the x-coordinate of the vertex is R plus S divided by 2. That's how you find the average. So it's going to be 6 plus -4 divided by 2, which is going to be 2 over 2, that is 1. So the vertex has an x-coordinate of 1. In order to find the y-coordinate, we plug in the equation and we're going to calculate the value of y. So I'm going to say y-coordinate of the vertex would be 3 times 1 minus 6. I'm subbing in for x. 1 plus 4. So that is going to be 5, negative 5. That's going to be negative 25 if you multiply. And negative 25 times the 3 is negative 75. So negative 75. So the vertex is located at 1, negative 75. That's the vertex. The question says, what's the optimal value? Well, optimal value is the y-coordinate of the vertex. So we're going to say optimal value is actually equal to negative 75. And we know that this optimal value happens to be a minimum value, by the way, because the parabola opens upwards, right? Because the value of A, 3, is positive, so obviously it opens upwards. And we do have a minimum point. The vertex is a minimum. And finally, it says, what's the equation of axis symmetry? Well, axis symmetry is that vertical line that cuts the parabola in half. So the equation of that would be x equals whatever the x-intercept, whatever the x-coordinate of the vertex was. So x equals 1. X equals 1 is the equation of axis of symmetry. I'm sure you're taking notes. The optimal value, which is a minimum value, is negative 75, and the vertex is located at 1, negative 75. This last question is sort of a word problem. It says we have some sort of toy plane, and this plane, like those drones, it flies in the air, and it has a package or a small parcel attached to the bottom, and it drops it, okay? So the height of the object that is being dropped is modeled by this equation, h equals negative 3t squared plus 27. T stands for time, and h stands for the height in meters. Now it says, what is the flight time, or what is the time to hit the ground when you leave this, when this toy plane drops the parcel? When does it hit the ground, basically? So hitting the ground, it means h is equal to 0. On the ground, height is 0, right? So we're going to say h equals negative 3t squared plus 27. We are going to factor negative 3 out because that's the common factor. And we end up with t squared minus 9. We are using our factoring skills in this word problem, as you clearly see. And then t squared minus 9 is, of course, a difference of squares. So that can be factored as t minus 3 times t plus 3. So that's the intercept form or factored form of this quadratic relation, basically. And the zeros of this relation are clearly r is positive 3, and s is negative 3. All right. So we have two zeros, two x-intercepts. And one of these x-intercepts is actually the point where the graph intersects the horizontal line, or the object hits the ground, basically. And that happens on the right side. So we're going to say here r equals 3 represents the time, which is 3 seconds, for the object to hit the ground. So we're going to say t equals 3 seconds is the time, or flight time, or the time required for the object to hit the ground. And time can always, must always be positive. So we cannot say time is negative 3 seconds. So that negative 3 is a sort of inadmissible solution. We're not going to accept it because time cannot be negative. But this other solution, r equals 3, represents the positive time, 3 seconds. So because it's a word problem, we're going to write the final closing statement or a paraphrase in your own words. As always, you're going to say the object or the parcel will hit the ground after 3 seconds. That's the statement you're going to write at the end. Okay? So it's just one example of a word problem for you. And we try to very quickly review this whole chapter, expanding and simplifying kind of questions, factoring questions, conversion from vertex form into standard form, or from conversion, I mentioned it, or finding the zeros of the relation, finding the vertex given the equation of the quadratic relation in intercept form or factored form. How do you do that? We reviewed all of these things that we discussed in the past. This was just a special session for your upcoming test so that you know what to expect, basically. So good luck and keep practicing, please.